Let's have a look at those questions. Down, 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 down. Go to the end. My goodness. Keep going. There we go. Alright, let's see what we got. A train is undergoing linear motion. The table below gives its velocity at different times. With the aid of a velocity time graph, compute the distance travelled by the train. That's not too bad. Beautiful graph or ugly graph? Which would you like? Beautiful? Okay. Only 3 questions.
Yeah.
Were you able to do all of them? Yeah.
I couldn't the last one though.
3D?
Yeah, because the graph isn't like.
Yes, the graph is weird, huh? Yes.
And for the it's okay. Let's just like go to number 3 first.
I don't know, we'll do 1, 2, 3. Unless you have a question about 3? Don't worry, we'll do them all. Do you have the table? Can you give me the numbers? Time.
0.
Wait, 1 sec, sorry. Time in seconds, and then velocity in meters per second. Hey. Okay. First time?
0.
Yep.
1, 2, 3, 4, 5, 10.
To 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then the velocity?
0, 5, 10, 15, 15, 10, 5, 0, 0, 5, 10.
Like this. Okay. Let's do our graph. Insert chart. Okay. Scatter. We'll do this one. Okay. Title, this is question 1. Time in seconds. Velocity in meters per second. Ah, beautiful. That is a beautiful graph. Okay, so the first question is to get the time. I wonder if I can. Yeah, I wonder if I can make more units on the x-axis. Scale, here we go. We'll do it in 1 units. Ah, yeah. Much better. That's great. Okay, so now we can. Actually, I can even do the y-axis as well, maybe. No. How did I do it last time? What did I just do a moment ago? What button did I click? Data ranges, was it? No. Yeah, that's what I'm thinking. Oh, hang on. Double click the. Yeah, there we go. Yeah, it worked, but it's too small to see all the numbers. Maybe I can make it a bit bigger. Okay. Oh, steady. Yeah. Ah, work of art. Now we can really see the area here because each box is 1 by 1. So the first shape is going to be a triangle from 0 to 3, and then 3 up to, 0 to 15. So that's a half times 3 times 15. So let's write that one down. Question 1 is a half times 3 times 15. Okay, what one's next? This is 1 times 15. So that's 1 times 15. And then next is a half of 2 times 15. And then next is 0. And then finally is a half of 2 times 10, is it?
Yeah.
Okay, so let's calculate that. Well, that and that cancels. That and that cancels. 1 is just 1. So this would be 1.5 times 15. 22.5? And then this is 15 plus 15, so that's 30 plus 10, 40, 50, 62.5 meters. Did you get that answer as well? No. What did I do wrong?
70 meters.
70.
Where's my mistake? Yeah, maybe, no.
Because the third one, maybe it's 1/2 multiply 3 multiply 15.
Or maybe it's multiplied 3? Oh, maybe because I'm no. It looks like 2. A half 2 by 10. Yeah? And this one is a half
Yeah.
3. Oh!
It's the same thing.
Ah, this is a 3. Not, okay, sorry. That's a half, and that's 3. Is this right now?
Yeah.
So that means this one here is not 30.
It's 32.5.
32
No, it's 32.5, right?
is 50.
Oh yeah, it's correct. It is, no, it's 15 plus 32.5. So
Hang on, I go. Look, I have a calculator.
it's 37.5.
A half times 3 times 15 is 22.5. $22.5 plus 22.5 plus 10. So what did you get as your answer?
70.
But you haven't plus the 15 yet.
Yeah.
What 15?
The
1
second.
multiply 15.
Oh my goodness, this is a disaster. Where's my pen? Plus 15. 70. Yes, okay. Okay, sorry about that. Plus 15 equals 70. My goodness, that was bad. Right, 70 meters. Okay. That's what you all got, was it? Yes, congratulations. Next. An elevator starts at rest, accelerates up to the next floor. It then accelerates for 2 seconds and then immediately decelerates for 2 seconds. In total, it travels 10 meters. With the help of a velocity time graph, work out the maximum speed of the elevator during its 4 seconds journey. So it's 10 meters in total, 4 seconds, and it's 2 and 2. Okay, so what's happening here? It'll accelerate for 2 seconds and then decelerate for 2 seconds. So the total here is 4. And I want to know what is the maximum velocity here. But what I also tell you is I also tell you the distance traveled. So that means the area here, I give it to you as 10 meters. Okay, did everybody have this picture, this idea? Yeah. So how can I find the velocity?
Half times x times 5 plus 10. X
Yeah.
equals 10 divided by 2.
That's it. So it's just not too difficult really. A half the base by the height should equal 10. So therefore V, well this will be 2V equals 10. So V is 5 meters per second. Yeah, that wasn't so difficult. Okay, yeah. Now the last one. So you have a particle and the particle is accelerated and then it's brought to rest. So it starts at rest, accelerates, and then slows and stops. So we want to plot this. Okay. So I need to, wonder if I can save my beautiful graph. File. No. Oh well. I'll just save the whole text file. Graphs. Okay. Question 2 now. Time in seconds and velocity is still meters per second? No, kilometers per second. Yeah. You did meters per second? We'll change it a little bit. Okay. What are the times? 0 to 10 again. Okay, and the velocities?
0, 1, 4, 9, 16, 25, 36, 18, 9, 40.
Like this?
Yeah.
Yeah. Okay. Chart. Question 3. Time in seconds. Velocity in kilometers per second. Great. Oh yeah, weird.
But isn't this just supposed to be a freehand graph?
Yeah. Yeah. No, you can draw straight lines between the points if you like.
But it would make sense because it can, like, nothing accelerates that way.
You never know. Things surprise you, you know?
But if I were to draw a freehand graph, would it matter?
No. But in the exam, they prefer to use a ruler between the points. Okay. We'll do ones again. Too many lines?
Yeah.
Yeah. Trees? Is okay? Yeah. Alright, so what's the first question? Let's see. Plot. Okay. Maximum acceleration, maximum deceleration. How far did the particle travel? So when you look at this graph, the slope is the acceleration. But the problem is it's not really a straight line. So all I wanted you to do with this question was to be happy with getting a rough answer, you know. So I know it's not a straight line, it's a curve. But what you can do is you can say it's like a straight line.
Are we supposed to take the steepest one?
You could also do that. I mean,
Find a gradient for the
yeah,
steepest
what looks like the steepest part?
the highest
This,
part.
do you think so? Like, if you imagine you're walking up this hill, where would it be steepest? You think 5 to 6?
Yeah.
I think so too, because each of these is 1 unit. So here the velocity increased by 1. You know, here it's about 2. Here it's about, you know, the heights of each little triangle is getting bigger. So I think this is the maximum acceleration. This is the biggest slope. And this looks like the maximum deceleration. So I'll just look here. So if I draw my triangle, how big is the base here? 1. And the height is 36 to 25. Yeah? Isn't it? I mean, you can probably see it on the table. Oh, I covered it up. This here was 25, and this here is 36. Okay. So the maximum acceleration would be 36 minus 25 over 1, 6 minus 5 if you want to write it in. So what's that? 11 over 1, is it?
Mm-hmm.
So 11,
Kilometers.
yes, 11 kilometers per second squared is the unit.
Yeah.
Okay, now this is the deceleration part, so I'll call that A2. So it's going down. It's going from 36 to, what was this number? 18? Okay. So that will be 18 minus 36 over 7 minus 6. So that's going to be minus 18. So the deceleration
It's 18.
is 18 kilometers per second squared. Now, don't worry if you didn't get the exact same answer. Did you get something close to this?
I got the same answer.
Okay. Amanda? No? No? Close?
No.
What did you get?
Nothing.
0?
Yes.
Oh, okay.
Just like a triangle and just half multiply 6 to.
You got the distance?
Yeah.
Okay. So you got these numbers? Fantastic. Okay. Lastly, how far did it travel? Okay. So did you get an answer for that, Amanda? The distance travelled?
No.
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 Grace? Did you get distance? No. So you got distance how much?
140.
About 140. Did you get distance? No? Impossible?
I mean, it's possible if it's like this, but I drew like the freehand ones.
Oh, okay, alright.
Like curves.
there's a couple of ways to do it, but I mean, I think if you do one big triangle, would that be too big or too small?
Too big.
Too big. You could then draw a smaller triangle. I don't know. You might even want to break it up into one triangle here, then one triangle here, and then one triangle here. I think that would be accurate enough. Okay. So let's do it like that. Let's do this triangle here. So that's a half 4 times, what's that number, 16?
Yeah.
So S, look, roughly a half 4 by 16. Okay, and then the next we'll do a rectangle 4 to 7, and the height is about 16 as well. So 3 times 16. Yeah. And then there's a triangle on the top which is a half of 3, and then it's 16 to 36, which is 20. And then, what do you think for this piece at the end? Sorry, we'll just do one triangle for the end here. A half, 1, 2, 3, a half 3 by 16 about, or 15. So roughly what do we get? Let's see. Pretty close to Sophie. 134 meters. And the computer program can give us the answer exactly. Okay, so let's see what the computer says is the exact answer. Let me just move this out of the way. Oh my goodness. Okay. So what I could do with the computer program is I could get the area for each second. So you make 10 shapes. So let's see what the computer says. Oh, come on, get out of the way. Where did my numbers go? Where did my numbers? Oh, there they are. All right. Okay, distance. So let me calculate this. So let me have a look at the shape here. It's okay. Right, sorry, let's do this. S equals U T. I think this will work. I hope it will work. So we're looking for something around about 135, 140. 122. Uh, 122. Okay. So my answer of 100 and okay. It's not great estimate, but it's not too bad. It's not too bad. Whoa. Too big. doesn't matter. Okay. The problem is, the reason my answer is too big is when I make a triangle, for example, like here, this curve is going to go under the triangle. Like, for example, the curve is going like this. So when I make my triangle, it's going to have a little extra piece in it. You see that? So that's why my answer is a little too big, because my triangles are a little too big. Okay. You have all the answers? Let me just write them down too. Okay, so the first one was 70, the second one was 5, and the third one 11, 18. Okay. Thank you. All right. We'll go to the next lesson. So, can I close this?